Hello everyone, this is Dr. Gajanan Jadhav. I'm working as an assistant professor here in Sri Shivaji Education Society, Amravati's Science College, Congress Nagar, Nagpur. The journey of light, welcome to this illuminating journey of light, not just into the science of optics, but into the deeper meaning of light itself. As Marianne Williamson said, as we let our own light shine, we unconsciously give other people permission to do the same. So the journey of light goes into the same way. The journey of light, which is an introduction to the optics. This is what I'm going to discuss with you today. As we know what is light, broadly we know that light is an electromagnetic wave. It travels through the medium in the form of waves and so on. But as far as the different theories of light concern, where they have studied the nature, characteristic and the properties of the light. So that starts with the Newton's corpuscular theory to the Huygens wave theory of light. It also moves from Maxwell's electromagnetic theory to the Max Planck's quantum theory of light, and then dual nature of light. So this is all we are going to cover in this particular video. Now let's begin with this small information as far as light is concerned. As we know that the formation of shadows as well as the images by mirrors and lenses has been understood by considering rectilinear motion of light rays. If you look at this particular diagram, then you will find that the rays which are coming from the sunlight, it falls on an object, it gets reflected, and those rays of light are collected by the eye. And therefore we'll be able to see the image of that particular object, we can say. So this is how we can perceive or how we can see the object. So it shows that this light is traveling in a straight line. There is a rectilinear motion of this particular light rays which are coming from the object and hitting into our eyes. Similarly, if you look at this particular, what we can say the figure, here you will find that this is the source of light which emits the light. It falls on this particular object, and after falling, you'll get the shadow of it. And remaining part, that is outer part of that particular object, will get lighted. So here there is a light, here there is a light, and this is nothing but the shadow of that particular object. So this is how a shadow is formed. So it is just because of rectilinear motion of light. That means rectilinear motion, light travels in a straight line, and that's why we are getting these kinds of things. We are observing these kinds of things. Let's go to the introduction of the light. We know that the formation of shadows as well as the images of mirrors and lenses has been understood by considering the rectilinear motion of light rays. This fact led René Descartes, that is in 1596 to 1650, to propose a particle nature of light in the year 1636. Then later on, Newton had developed this concept further and proposed that light is made of particles, and particles are nothing but the corpuscles. That is corpuscles which are hard, elastic and massless. Then later, a source of light emits these corpuscles which travel along straight lines in the absence of any external force. So this is the just introductory part of this particular light, where it starts from this particular man, which we call it as a René Descartes. He was a 17th century French philosopher and mathematician. R. Descartes to propose a particle nature of light in the year 1636. So this was the scientist who proposed that the nature of light is a particle. That means it travels through the medium in the form of like a particle, we can say. So Descartes viewed light as an instantaneous impulse transmitted through a medium of a particles. So it is a instantaneous impulse which gets transmitted through a medium of particles. This is what is said by this particular René Descartes. Then a force applied to one end of a stick is instantly felt at the other end of other end. That means if you apply the force to one end of a stick, then it travels to that particular stick and it reaches to the other end of that particular stick. This impulse travels in straight line, that is like rays, as we have just seen the motion, rectilinear motion, from luminous bodies and multiple rays can interact without interference. So here you will get the slight idea of the light, how that light, what is the nature of light, and how that light travels through the medium. So this is said by the René Descartes. Then later on, Newton studied the nature characteristics of light, and he developed his own theory, which is called as the Newton's corpuscular theory. What is Newton's corpuscular theory? The first scientist, Newton was the first scientist who attempted to explain the nature of light, and which was made by this particular scientist, which we call it as a Sir Isaac Newton. Then basically in 17th century, wave theory of light and corpuscular theory of light, these were the two major theories which came into exist. And Newton was first to publish in its, what we can say, the detailed form, that is in 1704, with the publication of his book, that is Optics. Now, what Newton's corpuscular theory said, that whatever the light is there, that light travels in the form of corpuscle. Now, what is that corpuscle? Corpuscles which are hard, elastic, and massless. A source of light emits these corpuscles which travel along straight lines in the absence of any external force. And the third, when the light corpuscles strike a reflecting surface, they undergo elastic collisions and as a result follow the laws of reflection. That means if you consider this light as a particle, that is corpuscles, which is said by the Newton, then it is traveling in a straight line. It hits this particular reflecting surface at this particular point of incidence, and these particles are getting reflected. So this is what's said by the Newton. Similarly, if you look at this particular diagram, then you will find that these are the incident balls. That means we call it as a corpuscles. These are traveling through a medium in a straight line. It hits the wall and it gets reflected back into the medium. So this is how, what we can say, the reflection of corpuscle is taking place as per the Newton's corpuscular theory. Now let us go into detail what are the assumptions of this particular Newton's corpuscular theory. So here you will find the first assumption, as we have discussed, the tiny particles. He said that light consists of tiny particles, that is called as a corpuscles, and having a negligible mass. It has a negligible mass. Second assumption, that particles, that is corpuscles, are perfectly elastic. Third, emitted from the luminous sources such as sun, candle, electric lamp. These particles are emitted from the sources of light. We know that there are different sources of light. Sun is the one of the biggest source of light, and it emits the lights. Similarly, we are having candle, electric lamp. These are the sources which emits the light. So basically, these corpuscles are emitted from the luminous sources, said by the Newton. Then travel in a straight line in all directions. That means light always travels in a straight line. Carries kinetic energy with it. While moving, when it travels, it will be in motion, and that's why it will possess a kinetic energy. Travel at high velocity, the speed of that corpuscle will be very high. Travel faster in the denser medium. Actually, these are nothing but the drawbacks of this particular theory. One, that is luminous sources, sun, candle, electric lamp, which emits the light, right? As we know, if we consider a chalk, and if a teacher writing on a board with that particular chalk, and if you consider that chalk, if we consider basically it is made up of the particles. So if you write on the board, that particular teacher will be able to write it on a board for certain time. Unless and until that particles get detached from it, he will be able to write. Once particle gets over, it will not be possible to write. But as far as the sun or candle or electric, basically sun is, if we consider a sun, then you will find that sun is the biggest source of energy, and it emits the light, and it is emitting since thousands of years. And if it is emitting corpuscle, that is particle, then obviously it should have come to an end, but it does not. So this is the drawback of this particular theory. Similarly, there is one more drawback of this particular theory, that is this tiny particle travels faster in the denser medium than in the rarer medium. But later this is proved to be wrong. That means we know, till now, we know that the speed of light in rarer medium is more than that of the speed of light in denser medium. Because the density of the rarer medium will be less, and that's why the speed of light will be more. The density of the denser medium will be more, and that's why the speed of the light will be less. So this is also one of the drawbacks. When this corpuscle falls on the retina of the eye, they produce image of the object and gives the sensation of vision, we can say. One more, that is assumption of this Newton's corpuscular theory, that different sizes of the corpuscle. He said that different sizes of the corpuscles, and that's why there are different colors of the light, right? So this is also, so in this theory, light of different colors corresponds to the colors, corpuscles of different sizes. That means as the size of the corpuscle changes, the color of the light goes on changing. So these are the few assumptions of Newton's corpuscular theory, where you will find some merits and demerits also. So basically there are two merits. One is the source, that is luminous source. If it emits the particle, then it should have come to an end. But it does not happen. Similarly, light travels in a denser medium fast, so that is also wrong. So these are few demerits of this particular Newton's corpuscular theory. Now, this is what I was talking about. Newton assumed that light travels faster in the denser medium than in the rarer medium, which has been proved to be wrong. Because we know the speed of light in rarer medium will be more than that of the denser medium. The assumption that the different colors of light are due to the differences in the sizes of the corpuscles has no justification. This is also one of the failure of this Newton's corpuscular theory. Newton assumed that reflection of light is due to the repulsion between the corpuscles and the reflecting surface, while refraction of light is due to the attraction between the corpuscle and refracting surface. So this is also one of the failure of this particular theory. Thus a medium could either attract or repel the corpuscles of light, but later this statement also was proved to be a wrong. So we all know that glass partially reflects and partially refracts light. How could then glass attract and repel the corpuscle of light simultaneously? And at last, corpuscular theory cannot explain the phenomenon like diffraction, interference and polarization of light, which is very nicely explained by the wave theory of light. So these are the very, what we can say, the failures of Newton's corpuscular theory, which we need to know them actually, if you want to know the nature and characteristics of the light. Then the next scientist came with his own idea, his study, and that is nothing but the Christian Huygens. In the late 17th century, scientists were embroiled in a debate about the fundamental nature of light, whether it was a wave or a particle. Some were saying it is a wave, some were saying it is a particle. So Sir Isaac Newton strongly advocated the particle nature of light, but the Dutch physicist, which is called as a Christian Huygens, he believed that light was made up of waves vibrating up and down. As we know that there are two types of waves. One is the transverse wave, another is the longitudinal waves, right? So if the vibration of the particles are perpendicular to the direction of the propagation of the wave, then we call it as a transverse wave. So basically up and down means this must be the transverse wave, perpendicular to the direction of the wave propagation, and therefore formulated a way of visualizing the wave propagation. So this particular theory, which we call it as a Huygens wave theory of light, came with the idea that light travels through the medium in the form of wave. So this was the scientist, and let's move for the Huygens theory of light now. This is the Huygens principle. As we know that every source of light emits the light. So let us consider here we have a source of light, and it is emitting light in all possible directions. That means light is traveling through this medium in all possible directions. So this particular formation of wavefront will be there. That means every point on a wavefront is the source of spherical wavefront. That means whatever the source of light which is emitting the light, okay, it forms the first wavefront. That is, we call it as an original wavefront, or you may call it as a primary wavefront. So every point on this particular wavefront behaves as a secondary source of light, as this primary source of light is there. And later on, it emits the wavefront in forward direction. So this is what we call it as a Huygens principle. This is the Huygens principle. So here you will find this is the original wavefront, and these are nothing but the secondary wavefronts. These are nothing but the secondary wavefronts. So you will find that every point on this particular primary wavefront acts as a secondary source of light and gives out the secondary wavefronts. Now, using this stated principle, Huygens successfully derives the laws of reflection and the refraction of light. However, he couldn't explain the diffraction effects of light. Later, in 1803, the experiment conducted by Thomas Young on the interference of light proved the Huygens wave theory of light to be correct. Because we know that there are different phenomena of light. When light falls on reflecting surface, it gets reflected. When light falls on refracting surface, it gets refracted. Similarly, if you are having two sources of light, and if they are emitting the light and they are traveling in the same direction, they get interference, and therefore we'll get the interference pattern. So this is proved by this particular what we can say the Thomas Young. Later in 1815, Fresnel provided mathematical equations for Young's experiment. So these are the few things which came into existence on the basis of this particular wave theory of light. Now these are the postulates of wave theory of light, which is said by the Christian Huygens. So the first postulate, that light travels in the form of wave. Light travels in the form of wave. This is the first postulate. Later it was proved that light travels in the form of transverse wave. Light travels in the form of transverse wave. That means we know the transverse wave, where the particle will vibrate perpendicular to the direction of the propagation of the wave. In a homogeneous medium, light waves propagate with a uniform velocity and move in a straight line. That means, as per this particular wave theory of light, he said that there is a homogeneous medium which is called as a luminiferous ether everywhere, and light waves propagate with uniform velocity and move in a straight line. Then later on, different colors of light. This is very important, because if you look at the Newton's corpuscular theory, Newton said that there are different sizes of the corpuscles, and that's why there are different colors of the light, right? But as far as this wave theory of light is concerned, Christian Huygens said that different colors of light are due to the different wavelengths of light. That means as the wavelength of light changes, the color of light accordingly goes on changing. And at last, there is one more. Light falling into our eyes gives the sensation of vision. That means whenever light falls into our eyes, it gives the sensation. That means we'll get the sensation of that particular light. Light waves are believed to travel through a hypothetical medium. This is also one of the very important aspect of this particular postulates of wave theory of light, and that is nothing but the luminiferous ether. As far as this particular wave theory of light is concerned, according to this wave theory of light, everywhere there is a luminiferous ether, and through that luminiferous ether, this particular what we can say the light is traveling, and that is hypothetical medium. That is nothing but the hypothetical medium. So these are the few postulates of wave theory of light. So then next, another scientist who came with the study of the light, nature characteristics and properties of the light, that is James Clerk Maxwell, with his own theory, that is Maxwell's electromagnetic theory. If you look at this particular diagram, then you will find that this is a wave, which we call it as an electromagnetic wave. Okay. As far as this Maxwell's electromagnetic wave theory is concerned, Maxwell said that light travels in the form of electromagnetic waves. And we know that electromagnetic wave consists of two fields. One is the electric field, another that the magnetic field. And these two fields are perpendicular to each other. They are vibrating perpendicular to each other, and they are also perpendicular to the direction of the propagation of the wave. Means here this electric field, magnetic field, and the direction of this particular propagation of light, that is, they are perpendicular to each other, and this is what we call it as a electromagnetic wave. So Maxwell said that light is an electromagnetic wave, and it travels through the medium in this particular like we can say the manner. Maxwell's electromagnetic theory, as far as the Maxwell's electromagnetic theory is concerned, the first aspect, or what we can say the thing about this particular electromagnetic theory, that is nothing but the unification. These equations unify. That means we know that there are different Maxwell's equations. He has given different equations, and those equations unify electricity, magnetism, and light, explaining phenomena from how generators work to the behavior of radio waves and light. Okay, and we know that electromagnetic waves itself is one of the what we can say the basic idea who came this Maxwell with that electromagnetic waves, and we know that is nothing but it consists of two fields, electric field, magnetic field. They are perpendicular to each other, and they are traveling in the direction of the propagation of the light. Then Maxwell's equation. These equations describe how electric and magnetic fields are generated and how they interact with each other, and the charges and currents also. So this is what we can say and the speed of light also. The speed of light was found to be approximately 3 into 10 raised power 8 meter per second by this particular theory. So these are the few things which are very important as far as this Maxwell's electromagnetic theory is concerned. According to Maxwell's electromagnetic theory, light waves are related to changing electric fields and magnetic fields. Just we have discussed that light waves are nothing but it is related with the changing electric and magnetic field. The change within electrical and magnetic field leads to the propagation of electromagnetic waves, or you may call it as a light waves also. The main points of this theory are, we can say, the energy emitted from any source continuously in the form of radiation and is termed as a radiant energy. The radiation includes electrical and magnetic fields oscillating perpendicular to each other and both perpendicular to the direction of propagation of the radiation. So radiation possesses wave characteristics and it travels with the speed of light, where radiations are known as electromagnetic radiations or electromagnetic waves, and these waves don't need any material medium for propagation. As we know that electromagnetic wave can travel through the vacuum also. It doesn't require any medium. Okay, so it can travel through vacuum also. So these are a few aspects of this particular Maxwell's electromagnetic theory. Then next scientist, that is Max Planck. He came with his theory about the light, and that particular theory is called or well known, that is Max Planck's quantum theory. Now, as we know that sun is the biggest source of energy. It emits the light, and it is the biggest source of energy, we can say. When it emits the light, as far as this particular Max Planck quantum theory is concerned, Max Planck says that it emits the bundle of energy along with it. It emits the packets of energy with it. And that tiny packet, or you may call it as a tiny packet of energy, that is what he called it as a quantum. So when sunlight or the source of light emits the light, it is emitted in the form of packet, or it is emitted in the form of bundles of energy, and that one bundle of energy or one packet of energy, we are calling it as a quantum. So this is the singular, one packet of energy. And likewise, if there are a number of packets of energy or bundle of energy, we may call it as a quanta. So quanta is nothing but the number of packets of energy. Number of packets of energy. Stop करून द्या.